In this lesson, we're going to talk about 32-bit versus 64-bit operating systems. You can see that Ubuntu 16.04 long-term support is available in a 64-bit version and in a 32-bit version. So what's the difference? Most modern computers are 64-bit. Most modern computers have 64-bit processors. And much modern software is designed to take advantage of that to give you better performance. A 64-bit processor can grab data 64 bits at a time, or in 64-bit chunks, and that's twice what a 32-bit processor can do. There were native memory limitations of 4 gigabytes with 32-bit processors. You could get around that if you're using a kernel that supports physical address extensions, or PAE. You are still limited to speed, though, in only being able to process 32 bits at a time. If you find yourself in charge of an older server and you're not sure if it's 32 or 64-bit, how can you find out? There are several ways. You could type uname -a, and then you can see it says x86-64. That means this is a 64-bit processor. You could type uname -i, or uname -m, like Mike, and get the same output for both of those. Your output for a 32-bit processor would be i386. But an even cleaner way is to use getconf longbit. And that just gives you a number, 64 for 64-bit or 32 for 32-bit. All things being equal, which they almost never are in the computer world, a 64-bit processor should be about twice as fast as a 32-bit processor. And you can see for some of these tests that's true. For other tests, though, the performance is the same. And for some tests, the 32-bit processor is actually faster. This is because software has to be designed to take advantage of the 64-bit capabilities of the processor. In this OpenSSL test, the 64-bit processor is about 4 times as fast as the 32-bit processor. So it really depends on what application you're running. You may be fine with a 32-bit processor. For this course, you're definitely okay with 32-bit. You'll never do anything that requires 64-bit processor. If you're running a web server, for example, that you expect to have a high volume of traffic on, or you want high reliability from, you probably want a 64-bit processor, if for no other reason than the hardware is supported and you can get replacements if you need to. In order to run VirtualBox or other virtualization software such as VMware Workstation or Player for Windows or VMware Fusion for Mac OS X, you may have to change some BIOS settings to make virtualization or 64-bit VMs work properly or at all. I wish I could walk you through an example, but the steps depend very much on what BIOS you're running. Please have a look at your BIOS for virtualization-related settings. They'll often be visible under the Advanced tab. You'll want to enable virtualization support and save your settings. If you don't find these settings easily, Google for virtualization support for your computer make and model. And that's it for this lesson on 32-bit versus 64-bit operating systems. And please remember, it doesn't matter which one you use for this course. Ubuntu could come in desktop or server. What's the difference between a desktop and a server, and why do we care? Why is it important to which operating system we download? Desktops are designed for different uses. desktops usually only have one user at a time. Your whole family could use one desktop or laptop, but you might have different logins for different people. Servers, on the other hand, serve many people at the same time, or could serve many people at the same time. They're designed to possibly serve many people at the same time. So they could have hundreds of users all trying to access their file shares on a file server at the same time. Or a web server that serves up web pages when they're requested from a user or from you. So you have to have a server up all the time. A desktop, if it's not up, well, you're going to lose your stuff or you're not going to be able to work until you fix it. But it's not a huge catastrophe and nobody's hopefully losing any money over that. So laptops and desktops also have some features and some things that you won't find on a server. So a typical laptop has a camera, microphones, might have a fingerprint reader. It has a trackpad, keyboard of course, a video screen that's capable of very nice sharp resolution, and it's kind of portable. And a desktop is very similar, except of course you can't carry it around. And it's not very redundant. In other words, if the hard drive fails on that, the hard drive's gone. Hopefully you've backed up somewhere. Please always back up. Or if the power supply dies, you can get another power supply. And again, very similar for a desktop. You'll have to go inside and replace the power supply, but not a crazy difficult thing. And again, your computer's down for a while. Well, that's not fun, but you'll get it fixed. And hopefully none of your data is lost. A server, on the other hand, if a server is down, especially for a company that runs on the internet or on its internet presence, if a server is down, that could mean loss of revenue. If a server is down for a long time, that could mean a company has a serious financial hardship. So you want servers to always be up. So servers have redundant power supplies, they have more memory, they have better processors, they have redundant hard drives. So if a hard drive dies on a server, just one hard drive and there's an array of many, then the server could stay up until you replace that hard drive and it rebuilds it into the array. A power supply similarly, if it has two power supplies, two or more, and one fails, it'll stay up until you replace that power supply. And you replace the power supply mostly to keep the redundancy. So again, if you had two power supplies fail, and you only have two, then your server's still down. So very different design considerations. Likewise with the operating system. So the operating system on a desktop or a laptop is going to have a nice graphical user interface or GUI, and it's going to have a lot of features that you'll want. It'll have an office suite. It'll let you easily install and use printers. It'll let you line up all your files in your video so you can see the little clips and pictures. You can see clips of your pictures and try and figure out which one you want to use. A server, on the other hand, is going to be kind of bare bones as far as what you can do with it through that. There's probably not going to be a GUI. There won't be if it's an Ubuntu server. But also it's going to be kind of limited in what you could do. From that perspective, it's not going to have a video camera. It's not going to let you sort your music in a nice graphical fashion. But it will let you manage the server using tools that are designed to manage servers. We'll go into bash scripting a little bit. That's shell scripting. It's a very powerful tool for managing servers. It lets you automate tasks that you have to do frequently. You can schedule those tasks so they run automatically and just give you a report. All those things are built in. And if you have a desktop operating system in Ubuntu, you can still do the things you can do on a server. You just go to the command line, you can type the same exact thing and do the same exact thing right on your desktop or laptop. So the converse is not necessarily true. If you learn how to do something on the laptop and you want to go find the graphical user interface on the server, it's just not there. So we'll have some more focus for the most part on the server side, and the graphical user interface will kind of guide you on the desktop side. So let's go install desktop and server for Ubuntu on VirtualBox.